How's it going, everybody? In this today, sorry, words they always escape me. Today, we are talking about solving equations. So, really, all that means is like back in Algebra 1, 8th grade, whatever, whenever you saw this, you had an equation. It would say solve. It would give you something like this. So you had to subtract the 4. You had to get the x by itself. Isolate the variable. That's really all that we're trying to do when we are solving equations. So you'd have 2x equals 4, and then you divide both sides by 2 so that you had x equals 2. We solved that equation, x equals 2, such that if I do 2 times 2, that is 4, plus 4 is 8. Solving the equation. That's all we're doing. So now, the thing that's more difficult about this is that we have some x's in our exponents. We have exponential equations. Later on, we will get to logarithmic equations. So those are kind of the two things that we're talking about. But really all we're going to do is just see how we use those things in order to help us solve equations. So here, this is an exponential form and this is an exponential form. So what I notice right away is that 16 is related to 4. And that 16, this part, is equal to 4 squared. So what I can do is if I make that the same thing as 4 squared, I'll keep that exponent the same out there, and then 4 to the 3x plus 7. Well, check it out. If I have something, 4 to the 2 and 4 to the something. So here, 4 to the something equals 4 to the something else. For these to be true statements, then 2 times x minus 2 must equal 3x plus 7. Since the bases are the same, base 4 and base 4, the exponents must be equal for this to be true. So once I know that, and if I rewrite this off to the side, I can solve my exponents, and that this would be 2x minus 4 equals 3x plus 7. Get like terms together. So if I subtract 2x to the other side, and if I subtract 7 to the other side, then x equals negative 11. Done. So if we can get the bases to be the same, we can take the exponents since they must be equal for this to be a true statement. So similarly, 4 to the x minus 4 equals 2 to the 2x plus 1. I can rewrite 4 as 2 to the second. Again, I will keep that same exponent on the outside of x minus 4, 2 to the 2x plus 1. So I have made my bases the same, so the exponents must be equal in order for this thing to be true. So since that's the case, I can take my exponents and set them equal to each other, such that now I have an equation that I can distribute the 2. And if I try to solve for x, I can subtract the 2x and subtract 2x. Uh-oh, I have negative 8 equals 1. Does negative 8 equal 1? Is that the same exact number? No, it is not. No, not even close. That's like 9 units off. So since we have gotten to the end, and that is not a true statement, this would have no solutions. There is no possible answer that I can put in for x such that those would be equal to each other. Say we did the same kind of work. We worked it down, and we get down to like 8 equals 8 or something like that. Don't forget that if this is a true statement, what this means is this would give us any real number. So all real solutions. Earthen. All right, with this one, same idea. So I notice that I have 81 and I have 1 over 9. Well, what I can do, 9 and 81 relate, and that 81 is 9 squared. So if I change that to 9 squared, now that's 1 over 9. Well, don't forget your exponent rules. I could rewrite that as 9 to the negative 1, and then keep the exponents on the outside. Well, cool. Now we have a base of 9 in both of them. So I can take my exponents now and set them equal to each other. And solve that equation for x. So I'll have to distribute. So I have 6x plus 2 equals negative x plus 4. Get your combined, words, Get your like terms together, so plus x minus 2 and minus 2, such that I'm left with 7x equals 2 divided by 7. So x equals 2 over 7. You could also write that as a decimal, 2857. Is that what that is? 2857. Yeah, boom! I did it in my head. But you don't know that, so I might as well have cheated. Which is about 0.286. Moving on. All right, so this one's a little bit more difficult. But again, it's still the same exact concept. We have exponentials. I can see if I can get my bases similar to each other somehow. So 125, if I think, I can rewrite that as 5 to the third, keep our exponent out there. And I can rewrite 25 as 5 to the second. Since those are both exponents or powers of 5, bases of 5, once again I can take the exponents and set them equal to each other. So I already multiplied the number in. That's how I'm getting the 6x plus 21 and 2x minus 16. And then combine like terms, because you love combining like terms. I love combining like terms. It's the greatest. It's the greatest, like Muhammad Ali! If you even know who that is. Hopefully you do. But I can understand as the years go on, you don't know who that is. I get it, I guess. All right, and then divide by 4, divided by 4. So x equals negative 37 over 4. Oh, happy day. I'm looking at another. So now we're really getting different because I could rewrite 8 as 2 to the third and 27 as 3 to the third. But since my bases are not the same, they are not the same, right? I have a base of 2 and I have a base of 3. I cannot just take the exponents and set them equal to each other. This is not just one. It would not work. So that will not work. So there's another option that we can do now. You have learned about logarithms. So this is in exponential form right now. So what I can do, my base is 8. So if I rewrite this in log form with a base of 8 of the other side, so log base 8 of 27 equals the exponent. Well, just doing that, I have gotten the x by itself. So now, the big issue arises in that if you press log on your calculator, notice it does not have a base with it. So this log, this base of this log, remember if it's not there, it's understood to be 10. So some of your calculators can do this, but I'm going to do this for the people that don't have this option. If we have a base other than 10 down here, what we can do is use our change of base formula that we learned about in the last lesson, such that it makes both of these a base 10 log. So now when I type in my calculator, I can do log 27, close your parentheses, divided by log 8, and my answer will be 1.585. And that's it. So x is approximately 1.585. That's what I'll be looking for on those. All right. Getting close, getting close, getting close. Kind of. All right. Again, same idea. I cannot rewrite 6 as 3 to the something, but I can rewrite this in log form as log base 3 of 6 equals x plus 1. I cannot type that in my calculator, but what I can do is I can do log 6 over log 3 equals x plus 1. I can determine what log 6 divided by log 3 is, so log 6 divided by log 3. And then since I have this x plus 1 over here, I know I need to get x by itself, so just subtract 1, so minus 1, and my answer is 0.631. So x equals 0.631. All right, moving on. And this one, again, we have x in our exponent, so it'd be nice if we could rewrite them. But since this e is not with this 6, I can't make them both be base of 6. And if there's a number, notice this is not in parentheses. So this 2x exponent is only applying with the e. These go together. This does not go with our 6. So what we need to do first is go ahead and divide that 6 since it's multiplying e to the 2x. So I have e to the 2x equals 6, 36 divided by 6. Now I am in exponential form. So I can rewrite this in logarithmic form. If the base is e, this is a natural log. Again, remember the base is understood to be e for natural log. So natural log e of 6 equals 2x. I can type in ln 6 because it has an ln button right there. So ln of 6. Oh, that doesn't work. There she is. Ln of 6, and that is 2x. So I need to divide that number by 2 to figure out what x is. So we have 0.896. So x equals 0.896. Well, happy day. All right. This one has a little bit more junk. So what we can do is, because I want to get the exponential part by itself. I want to get that by itself first. So what I have stopping us is this 2 times it and this 6 adding to it. So it would be nice if I could get rid of this 6 such that I have 2e to the 3x plus 4 equals 12. And then I can get rid of this 2 by dividing both sides. So I have e to the 3x plus 4 equals 6. And then again, we're stuck in exponential form. So I can rewrite this in log form. The base is e, so my base is a natural log, is e with the natural log. So natural log of 6 equals 3x plus 4. So again, we will start off with ln 6. So I have ln 6, and then I can subtract 4, so ln of 6 minus 4, and then I'll have to divide 3 equals x. This 4 does not, no, 9! Do not do it. This is not natural log of 2. No. Natural log of 6 is a number by itself. It's its own special thing. Focus, camera. So if I'm subtracting 4, I need to type in ln of 6. So ln of 6 first, then minus 4, then divided by 3. That is our answer, that negative 0.736. So approximately negative 0.736. And you can always check your solutions. Like, we know that 2 times e to the 3 times that number, so 2 e to the 3 times our answer, plus 4, and then plus 6. This is supposed to equal 18. So, does it? Hey, it does! We did it right. So please, 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 as you guys are going through this, check your answers. If it doesn't work in the original equation, then you did something wrong. Go back and look at your math. Try to figure it out. All right, moving on. These ones are super simple. I love these. Let's check it out. Just like earlier, if we had the same bases, we have the same base here, log base 2 and log base 2, then the insides must be equal for that to be true. Well, then that means x must be 12. Ha! Yeah! Okay, same idea. The bases are the same. I have log base 2 and log base 2. So the insides of the log must be equal for this to be true. So x minus 3 equals 24. So x equals 27. Yeah! All right, here, a little bit different because we don't have another log. But what we can do is this is now, this is in perfect log form. So I can say 2 to the 3rd equals the thing inside. Whoa, that really did it for me. So 2 to the 3rd is 8, so x equals 8. Hey, I got the x by itself. Again, we're in log form. So maybe if we rewrite it in exponential form, it'll be useful. Well, if I do 2 to the 1st equals the other side, x plus 4, subtract the 4 to the other side, 2 to the 1st is just 2. So minus 4, negative 2 equals x. Hey-o, I have a solution. Easy money, easy money, easy money. 3 more. Tres más para ti. Yeah! Ah! All right, here, again, base of the natural log, if you do not see it, is e. This 2, so I want it to be in natural log form. I want the log to be by itself. This 2 is what is stopping us from being by itself. So if I divide by 2 first, on both sides, I have ln of 2x equals 4. And then what I can do is rewrite this in exponential form. So I have e to the 4th equals 2x. So now it's just a matter of dividing by 2 to get the x by itself. So I can type in my calculator, you have an e to the button, e to the something. It is right here above natural log that says e to the x. It's kind of hard to read, but that's what it says. Just what it says, I promise I do. So I have e to the 4 divided by 2. So I have my answer is 27.299. So x equals approximately 27.299. All right, doing good. Moving on. Almost done. One more after this. So here again, get the log by itself first. So I need to minus 5. So I have 6. ln of x equals 0. I need to get rid of the 6 in front. So divide by 6. So ln of x equals 0. What is the base of natural log if you don't see it? Oh, good job. Good job, Cora. That was weird. I didn't know she knew algebra 2 stuff. It's crazy. So if we do e to the 0 equals x, don't look at me like that. I know you know algebra 2. Shut up, dog. So anything to the 0 power is 1. My answer is 1. I'm done. Well, last one. Same idea. If you see a log and there's only one log, try to get the log by itself. So I have log base 2 of x minus 3. I need to get rid of the 7. So minus 7, minus 7. So I have 3 log base 2 of x minus 3 equals 9. Then get rid of that 3 in front by dividing both sides by 3. So log base 2 of x minus 3 equals 3. So now I'm stuck in log form. So what I can do is rewrite this in exponential so that I have 2 to the third equals x minus 3. 2 to the third is 8. If I add 3 to it, plus 3, then I have x equals 11. All happy day. All right, please, make sure you guys practice this stuff. Make sure you guys plug in your answers, see if they work. I thought I heard a ghost. That was terrifying. There's somebody in my house. All right, I'm gonna go. I'm gonna go now. I'm gonna go beat them up. Wish me luck. Bye-bye.